Yeah, so thank you for that, and thank you also for organizing this webinar series on PHENET. And so I will take a few minutes now, the 20 minutes, to present about our use case, which is about the farms to platform use case. So where we are trying to see how small private actors can leverage from the research infrastructure's capabilities in order to support innovation and new services towards the agroecological transition at the farm level. I was also saying that this use case is led by the UC Louvain, so by Xavier, Pierre de Fournier, and Tom Kenda. And I'm Arthur Monhonval, so from Soil Capital, which is a private company that is supporting farmers to their transition to regenerative agriculture. So the point also of PHENET is mostly a society-driven project, and it's also to help catalyze the transition of farmers to more agroecological farming practices. And this is a need because we know that now the farmers are in a kind of a hard spot linked to the climate hazards. We already seen that this year the yields were quite dramatically drawn down because of the climate this year. And there's also quite a need for some constant supply of food and feed commodity for food, beverage, and agriculture. There's also a need for the farmers to have a long-term profitability. So also there are socioeconomics levers into this. And we are trying also with UC Louvain to co-create some new services and tools so that we can help farmers to find this new equilibrium and to transition to more sustainable agriculture. And this is designed to provide first climate benefits on the carbon side, so to reduce the carbon dioxide and methane emissions and nitrous emissions from agriculture, increasing the carbon removals that agriculture can support, but also strengthening the other types of ecosystem services that are not linked to carbon, so going beyond carbon, looking into biodiversity, water management, etc. So maybe in order to better understand our use case, I will first need to make a small introduction about Soil Capital and what we are doing at Soil Capital. So we are a company that is dedicated to regenerative agriculture since 2013. So in 2013, it was first seen as an advice company to farmers. We are giving support and advice on how to transition to more sustainable land management practices without impacting the yields or lower income for the farmers. And so what we are trying to help them with is to provide context-specific advice in order for them to maximize their soil cover, so putting cover crops in the year, minimizing the soil disturbance, so having the lower plowing as possible and increasing the no-till systems at the farm. We are also trying to help them adapt their fertilization strategy, so reducing the synthetic fertilization and increasing the organic part, and trying to diversify the crop rotation. So as I said, so Soil Capital is an advising firm since 2013. But since 2020, we have now opened what we would call a carbon program. So this carbon program is now been running for almost 5 years. And in those 5 years, we have engaged with more than 1,600 farmers. And so these farmers are every year engaging with us. We are quantifying their carbon removals and greenhouse gases emissions reduction. And depending on their improvement from one year to another, we reward them financially. And so we've already paid 2 farmers those last 4 years to 9.5 million euros total, so spread among the farmers. And this money is mainly investment from food and beverage industries that are investing within their own supply chain, so to farmers in which they are supplying their commodities to transform the products. And so this is mainly food and ag companies investing to their farmers in order to reduce their Scope 3 emissions. And so in order to do that, what Soil Capital does as well is to collect many farmers' data relating to their farming practices and their soil characteristics. So when I say about farming practices and management practices, it's mainly about their crop rotation, their tillage system, their cover cropping strategies, how much fuel they use on their farm, and all of these different things that are important in order to be able to quantify any types of greenhouse gases emissions and carbon removals. So we are using both sampling, we are using a process-based model in order to estimate the dynamic of the soil organic carbon, carbon dioxide emissions, nitrous oxide emissions, and methane. And we are also using remote sensing in order to verify and monitor those practices in the long term. So this is a map just to show a bit how many farmers have joined Soil Capital since 2021. So you see the date above there. So this really shows that using this farm community, so we can really cover a huge diversity of different agroecosystems. And all of these farmers are not highly regenerative. Some of them are conventional. And therefore, this can be really useful to set up a collaboration within PHENET in order to translate field data and EO, Earth observation data, in many different types of conditions, farming practices, and pedoclimatic conditions overall. Of course, we will not put IoT sensors in all of those fields because this is not the scalable option. But this is why we are trying to fuse data between Earth observation and IoT sensors across different spatial and temporal scales within PHENET. And so what we do at Soil Capital and how PHENET is helping in our search of this with their services and their knowledge is that how a program is rewarding farmers on their improvements. So the first metric we used in order to reward those farmers was mainly dedicated with the carbon focus, so mainly about the carbon removals they can have on their farm, or with the greenhouse gases emissions reduction they can have on the farm as well. And now we are trying to co-develop within Soil Capital and with the help of UC Louvain and other partners from PHENET to broaden this to more than carbon and to have an holistic view that is integrating also the water management, the climate, soil health, biodiversity, and farm economics. And so what we are doing is that we are supporting thousands of hectares to regenerative transition, and the integration of beyond carbon metrics, so such as biodiversity, is a need both from the farmers that wants to have not only a carbon quantification of their footprint, but a more holistic view that takes into account other types of ecosystem services. And this is not only a view from the farmers, it's also a view from the companies and industries that are buying certificates in order to invest in their own farm improvement. So this is a need that is both from the farmers and from the food and ag industry to have these types of indicators. So now the question is, how can PHENET support, improve, and upscale this type of indicators using research infrastructure services? And so I will dig a bit more into how we can go to this type of indicators that takes into account the different types of components here. So within Soil Capital, we have the ability to have a lot of data that are encoded by farmers, but these data are sometimes lacking for certain aspects, and sometimes they are not scalable, and encoding the data from farmers is really time consuming as well. Therefore, this is why remote sensing and IoT sensors are useful. So we could use IoT sensors in the field first to quantify and calibrate some hard-to-get parameters, and the calibration of these IoT services with remote sensing could then enable to have an upscaling with a cost-effective way to have this type of index through all of our farms. And so this indicator is divided into 5 components. So there was water, farm economics, climate, soil health, and biodiversity. And all of these big components are subdivided into domains, and those subdomains are divided into indicators. So as of today, we have roughly 32 indicators. So that it's more than the ones just displayed here on the plot. But for these indicators, we need something that is normalized with a scientific anchor. So the thing is that each of these indicators is then scaled in a 0 to 10 scale. And in order to normalize this, we can use also the knowledge of the PHENET community related to soil health, related to phenotyping, or other types of data. And one of the use case also that we will try to do by using those IoT sensors and remote sensing within the soil capital farm community is also try to provide some evidence on the climate resilience of regenerative agriculture systems based on those metrics compared to other types of conventional farming systems. So how to leverage from the research infrastructure? So as I said before, there is the remote sensing expertise that Xavier also presented at the beginning of the webinar. The IoT sensors capacity to build those and to set those on the field, and the phenotyping knowledge transfer. And so, as you've seen, at Soil Capital, we have many farmers covering many landscapes and having many different types of management practices. And they could really be used as scientific objects, let's say, or as a real laboratory in order to be sure that those IoT sensors and remote sensing device are really scalable to any type of agriculture in France, Belgium, or anywhere in the EU. And the IoT sensors will also be used in situ to test the challenge, how regenerative farming systems can benefit from those practices rather than the conventional ones. So to go a bit in the details of this case study, the case study is also mainly to study the resilience of regenerative agriculture to climate hazards by comparing the regenerative practices and the conventional practices. And so one of the first steps will be to use IoT sensors in situ in order to help calibrate remote sensing spectral data. So that was really how can we fusion data across spatial and temporal scales. So using IoT sensors within the field, trying to upscale this signal using the remote sensing calibration afterwards. And also to provide solid evidence of the higher resilience to climate hazards for crops that are grown under different practices. So in order to do that, there are different things that needs to be considered as preliminary steps. So before putting the IoT sensors in the different fields. So the first thing to consider is first to have the crop type that is sensitive to climate hazards. So the idea would be to put those sensors in fields from Soil Capital around next year. And we've seen that already this year, climate hazards already happened. So we had some droughts, we had some floodings. Therefore, it's not only about the future climate scenarios that is into play, but already today's climate hazards that have sometimes a big burden on the farmers' profitability and yields. And so this is a way that we should find crop types depending on the phenotype of the crops to see which crops are the most sensitive to the climate hazards we had, for instance, last year. We should also dedicate this study to areas that are cultivated on soils that are characterized with low buffer effect on climate hazards. So if I maybe give some color to that, what I mean by low buffer is that depending on the soil organic carbon content of the soil, so the soil organic matter within a field, a field that has a really high soil organic matter will be less vulnerable to a drought or to a small drought within the year or within the growth development of the vegetation. And so what we would look at is low sock areas, so soils that have a low buffer effect on climate hazards, so that as soon as a climate hazard happens on the field, it can be transferred or signaled and measured by the IoT devices or also by remote sensing. So the IoT sensors to be implemented on the field should be in homogeneous conditions. So this part is mainly linked to the field heterogeneity algorithm. So this point is that all the work that has been done in work package 3 that Xavier already introduced before about the heterogeneity algorithm is that this could be used as a decision tool to know what is the best trial location to put in situ sensors. So the way to see this is that we should select the field which is the most homogeneous, so that the remote sensing data are also homogeneous within this field, and so that we can put the IoT sensors in the homogeneous areas within the field. And so this tool, this partial heterogeneity algorithm, has already been tested in some of Soil Capital's fields. Thank you, Tom, for that. And this will be a preliminary step to select which fields will be selected in order to put the sensors into the next monitoring steps. So if I go back to the previous slide, so there was this point about the homogeneous field question. The second question was to have IoT sensors that can support long-term in situ monitoring. And so this is another step that has already been made, which is the development and the testing of the IoT sensors. So Xavier also documented about this, about the different sensors that was available. So there was temperature and air moisture sensors, spectrometers for the incident solar radiation, and spectrometers for the crop reflectance signal. And the testing that has been done already in some UC Louvain fields pointed to various improvement needs, so mainly about the water tightness, about the communication system, so having a LoRa or GSM data transfer system, and some new sensors already tested, such as the canopy infrared or camera settings as well. And last but not least, in order to make this type of assessment of regenerative versus conventional practices, we should study areas that have similar pedoclimatic conditions, but different farming systems. And so for this, we can easily select within the multiple farms we have at Soil Capital to select the ones that are in similar pedoclimatic conditions. And based on the encodings that we do at Soil Capitals related to the managing data of farms, we can select easily the ones that are more regenerative and the ones that are more conventional within the same area in order to have these contrasted conditions in order of farming system. So when I say that we have a well-documented portfolio of farms, is that within these 1,600 farms at Soil Capital, all of those farms have encoded their crop rotations, their history, so we can go back 2 to 3 years sometimes in the farmer's strategy. We have data on the tillage, cover cropping, we know the dates, we know the type of diversity of the cover cropping, the biomass, and so this can be used in order to find the best candidate to test this case study about the resilience of crops. And so what should be the next step? So now the IoT sensors have been tested once already, and they are also now in the second phase of testing at UC Louvain. When those IoT sensors will be ready, we can start to implement them in Soil Capital fields that will be selected depending on to find the best candidates within our portfolio to answer this research question, which is to remember how can regenerative practices or conventional practices impact clearly the crop resilience, or at least leverage or minimize the impact of climate hazards to the crops. And the research infrastructure services will help to provide those IoT sensors and to interpret the data. We also have some remote sensing expertise about, okay, how can we calibrate IoT sensors and remote sensing, what data or what spectral imaging should be used in order to calibrate those, and also some phenotyping advice on the crop behavior to climate hazards. And so PHENET is also a big project where it's society driven, and it's the place where we can co-create new types of services or new types of tools that can be used by private actors on the field or already by the farmers in order to answer some of their needs. And the needs of farmers today is really to help them to have a prosperous or a profitable agriculture activity, which is really difficult today in the farmer's mind. So there's really a big mission there that I'm happy to have alongside our PHENET partners. So thank you for listening. So please feel free to contact us if you have any ideas, if you want to be involved, or if you have any questions on what we do. So thank you very much.